The hardest part of Europa Clipper is not simply reaching Jupiter. It is surviving once it gets there. Jupiter is beautiful from a distance, but around it is a fierce magnetic environment. The planet acts like a giant natural particle accelerator, trapping charge particles and whipping them through space. Near Europa, that radiation can damage electronics, interfere with instruments, and slowly wear down a spacecraft that has to keep thinking clearly for years. This is where the mission becomes an engineering story. If Europa is the prize, Jupiter is the gatekeeper. One obvious idea would be to place the spacecraft in orbit around Europa and study it continuously. But that would expose the spacecraft to punishing radiation again and again with little relief. So Europa Clipper uses a different strategy. It orbits Jupiter, not Europa, and makes many planned flybys of the Moon. Each encounter is brief but valuable. The spacecraft dives, close gathers data, then moves back out along a wider path where conditions are less severe. That approach is a compromise, and space missions are full of compromises. More time near the target usually means more data, but more time near Europa also means more radiation. Engineers have to balance science, ambition, against survival. Inside the spacecraft, sensitive electronics are protected in shielding, sometimes described as a vault. Instruments and systems are built with the expectation that the environment will be unforgiving. The spacecraft also needs large solar arrays because sunlight at Jupiter is much weaker than it is near Earth. It must generate power far from the Sun, communicate across enormous distances, and perform precise navigation around a giant planet with many moons. None of this removes uncertainty. Engineers model the radiation environment, test hardware, and build in margins. But space is never a laboratory with perfect conditions. A spacecraft has to handle cold radiation delays in communication, and the simple fact that no one can repair it by hand. That is what makes missions like this so impressive. The science question is, ancient could there be a life-friendly ocean beyond Earth? But the answer depends on modern engineering, careful planning and patience, measured in years. The hardest problem is not a side detail. It shapes the entire mission. It decides where the spacecraft flies, how long it stays, what it can measure, and how safely it can bring its observations home. And if it succeeds, those observations may guide the next step in ocean world exploration.